Okay, final part, extension work. You've already done this skill, covered this skill. So you would have n factorial over 2 factorial and then take 2 factorial, the difference between them. What did you do? You had to get them to cancel down a bit. So if we change the denominator to n times n minus 1 times n minus 2 factorial, you'll see they cancel. 2 factorial is just 1 times 2, so we could cross multiply by 2 and then expand open and bring over so it equals 0. What did we do then? We factorised, so 5 times 6, it has to be minus 6 to get the negative 1, and then we solved. And remember, it was a positive integer, so you had to have n equals 6 only. I don't know if you remember, you completed those, okay? Obviously, it can be tougher. So what I'm going to do is these three. If you want to try them without any influence at all, then you can go ahead and try it. But I think you'll be best watching these, and then I've got 4 for you to try afterwards. Okay. So 2n, put a bracket around it. So it's 2n factorial over 2 factorial and the difference between them. You need to manipulate so they cancel. So I can call this 2n times 2n take 1 times 2n take 2 factorial. Then you can see that these cancel. I could reduce down the 2's here, but I'm going to cross multiply just in case anybody did so. And then open up. So you've got 4n squared minus 2n minus 552, or divide by 2 at that point. Okay, so it's 1 point I expect you to divide by 2. Doesn't matter whether it's up here or whatever. Open up, so you've got 2n squared minus n minus 276 equals 0. And from there, then what I'm looking for is for you to try and factorise it. It's not the easiest to factorise because it's not just the difference between two numbers. You've got a 2 in here as well. So you would have to use trial and error to try and figure it out. I would maybe think about halving it and then dividing it by 4 and so forth and just trying out some numbers. Okay, so then we come up with this because you get minus 24 plus 23. When you go to solve this, you end up with 2n equals minus 23, so n equals minus 23 over 2. You're not allowed a negative and you're not allowed a fraction, so it's out. And then this one here must be 12, so there's your answer because it's more than 0, and on top of that it's a whole number. Remember, it's supposed to be natural numbers, 1, 2, 3, 4, 5, 6, 7, on and on. Right, bit trickier for you. So we've got n factorial over 3 factorial and n minus 3 factorial. We need to manipulate the top so they could cancel a bit. So we'll have n times n minus 1, n minus 2, n minus 3. Then these cancel, can you see? So then we end up with, if we cross multiply, 120. And then we can open up, so that's n squared minus 3n plus 2. And then multiply and move around. I wish things would stop making noises around here. Okay, right, okay, so the next thing, how on earth do you factorise a cubic? In the past, how did you do it? We used synthetic division. So what we're going to do is try something that's a multiple of 120. There's a 3 and a 2 there as well, so I'm going to go for 6. So that would bring down 1. 1 times 6 is 6. Collect together, you get 3. 3 6s are 18. Then we get 20. 20 times 6 is 120. And before you know it, we've solved it. I could write n equals 6 is a solution because it has a remainder of 0. So n minus 6 is a factor, but I'm just going straight to this. So it's n take 6 times n squared plus 3n plus 20. As there's no negatives, I've got no idea how I'm going to get a 3 in the middle. So I'm going to try out b squared minus 4ac. And what I find is I'll get 9 minus 80, which is negative. So I don't need to find the answer. I'm just saying it's less than 0. You can say it's minus 71 if you want. But at the end of the day, there's no solution there. So n equals 6 is the only solution because you're allowed positive integers only. Nice. Right, okay, similar idea. N factorial over n minus 3 all in a bracket factorial. And then the difference between them, and remember to put it in a bracket. So what happens is you end up with n take n plus 3. The n's cancel out and you end up with pretty much the reverse of the previous one. So you need to manipulate to get the n minus 3 again. You'll see they cancel then. 3 factorial is not 3, remember it's 6. So if you cross multiply, multiply by 6. And then I've already opened that up before, so I know that part pretty much off by heart now. Open it up, multiply by n, and move over. How is it you deal with cubics? Synthetic division. Now we could try zeros, twos, not zeros, twos, fives, whatever. I'm just going to go straight to a solution because I know that's not the part that you're trying out here. You should know how to do synthetic. So that means that I have n minus 11 times n squared plus 8n plus 90. Okay, so we have to yet again see if anything factorizes here. I don't think so because I can't think of two numbers that will give me 8. B squared minus 4ac, I'll sort that one out, and then you get 64 take 360, so there's no solution, which means there is only one solution at n equals 11. It's nice, isn't it? So now you can try 4. So I've got 4 there for you to try. I'm going to whisk past. So I've got solutions there in answers, but you can use the PDF to check them out. Okay? Right. Now, what about brackets? Man alive, how are we going to do this? So what we have here is we can square that one, no problem itself. So that's just straight off, no hassle at all. But here we've got a tripler. And how on earth are we going to cube it? So what we're going to create is a bracket within a bracket. So it's quite involved, this. So we're going to focus on this, and I would suggest taking the constant in the bracket within the bracket, and preferably the easier parts, because what I've just created there is another binomial expansion within one. So you know it's to the 3, so it's 3, 0, 3, 1, 3, 2, 3, 3. You know that this one will be to the power of 3, 2, 1, 0, and this will be to the power 0, 1, 2, 3. So I'm doing this fast because you know this process. I'm just showing you how to cope with extreme examples. You know that that goes 1, 3, 3, 1. You know that's to the power of 3, power of 2. I don't need a power to write on it, and that goes to 1. You know that is 1. You know that's just x squared. That'll go x to the 4, and that'll go x to the 6. So that's where I've got to here. The only thing I've done between this line and this one here is I've got no reason to write the ones everywhere. And I've brought the x squared and the x to the 4 and the x to the 6. So I've smartened it up. What I'm going to do now is not even try to continue with that. What I would normally do is actually these at the side on a different piece of paper or in a double-sided jotter. I would maybe do these on one side and the question in the other. So now I'm going to focus on this, which is another expansion in the expansion. So we know the power of 3 off by heart goes 1, 3, 3, 1. So I'm just going to go through this. You know that this will be the first term, so it'll be 1 to the 3, 2, 1, 0, and the 2x will be to the 0, 1, 2, 3. I know it's messy, but I'm just doing it fast, okay? So then you know it's 1, 3, 3, 1. You know all the ones are just ones, and you know that's 1, 2x, 4x squared, 8x cubed. Nice. So then we can simplify and get 1 plus 6x plus 12x squared plus 8x cubed. It doesn't take you that long, okay? Right, so now what am I going to do? Back to this part here. We have already talked about expanding this, so this is where I stopped in the previous one. Instead, what we're going to do is put in your expansions now. So now that you have expanded it, because ideally you would have done it at the side, I'm going to substitute it in. So that's what the cube does. I know what the square does by just mentally doing it, so I can now place the expansions in. Let's multiply it out. So the first one's just as is. We're going to times by 3 and increase the power by 2. Okay, times by 3, increase the power by 4. I've deliberately used colours here to show you that I've not made all the same powers, the same colours, it's just the expansions, so that you can collect anything with a constant, anything with an x, anything with a squared, and it's actually not that bad, okay? So you get your answer. But I'm flying past that answer to show you the reason I put the colours. You could stagger an addition. So if I put the first part, which is the navy, and then the next part starts with x squared. So if I put that under the x squares, and then this green under the x to the 4s, then I have an addition sum with 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the 4, and there you go. It's the same as the purple one. It's just quite nice a way to actually add them all together. Right, let's get back to the question. So the question at hand was actually that. We expanded this in our head and now we have a full expansion for that. Do you remember right at the beginning of this whole section, I made a multiplication grid to do x to the 4? Well, that's what I'm going to do now. So we're going to set it up so you've got the longer one at the top, just so I know how much space I need. I should be able to fit it in. And down the side, I'm putting the other one. That means that I'm going to increase multiplying. I'm not changing the coefficient, but I'm going to multiply the power by x squared. So it's going to increase by 2. That's easy enough to do, isn't it? Now I'm going to double and increase by an x. And then I'm just going to write the exact same line. So what do I have then? What you'll notice, the reason for the grid again is to make it super easy. Could you imagine having them all over the page? Then you can see you've got x to the 4s all together, you've got x to the 5s, x to the 6s, x to the 3s, x to the 2s, x's, on and on. Diagonally, you can collect them. So you've got 1 plus 8x. So I've got 1 plus 8x. I've just moved this a bit. Plus, then you've got 20, 30, 56. Sorry, it's 28x squared rather. Okay, plus 56x cubed, plus 40, 50, 60, 70x to the 4, 56x to the 5, then you've got 28x to the 6, and 8x, 7, and then x to the 8. The last part is actually not that bad if you use a grid, okay? But what a question, okay? So what did I do? I started by expanding the first bracket, no problem, and then with the second one, I made a bracket within a bracket. When you know that, I would suggest at the side you expand these separately so that they're not getting in the middle of the question, and then slot them in, open it up, and then make a grid. Okay, right, there's your challenge. I've just made 2 for you, so expand easiest, try to get an integer as part of the internal bracket of the tripler, if that makes sense. Expand the things separately, use a grid to multiply, and you'll collect them together. So there's the challenge. Okay, I've got them here in the PDF. I'm just going quickly through. Yes, they are a bit messy, but wow, have a go at that. And that is you finished binomial expansions.